morning, viewers. This is Kasturi Day. Today, again, I've come to discuss the atomic structure according to ICSE syllabus, class 8. Okay, so today I'll start with isotopes. Okay, in the last few videos, I was discussing about the single atom, okay, of an element. Now I'm coming to isotopes, which means there are atoms of the same elements which have the same atomic number, but the mass number is different. Okay, so here what do we see that there are maybe of single element, there may be two atoms which has different mass number, which have two different mass numbers, but atomic number of each of the atom of the same element is same. Okay, for example, see protium, which has hydrogen, mass number is 1 and atomic number is also 1. Deuterium, mass number is 2, the atomic number is 1. Tritium, mass number is 3, but atomic number is 1. But all of the three have the same symbol because they belong to the same element, that is of hydrogen. Okay. Now, we come to the properties of the isotopes. As the isotopes of an element have the same atomic number, therefore they have the same chemical properties. Okay, so their chemical properties does not differ. Okay, atomic number, as their atomic number of the atoms of the same element, they have the same atomic number, is the same. Therefore, their chemical properties will be the same. Even if they have the same atomic number, or as they have the same atomic number, all the isotopes of the same element have the same electronic configuration, because atomic number is equal to number of protons or number of electrons. So as the atomic number is same, therefore the number of protons and number of electrons, that are also same. So for they have the same electronic configuration. Okay. Now, due to their difference in the mass number, as the mass number differs, therefore the isotopes will have different physical properties, like the density, the melting point, the boiling point, that those properties will differ in the isotopes. Okay. Next is contradictions of Dalton's atomic theory. See, from the latest researches, Dalton proved that in the previous researches, Dalton said that the atoms of the same element, they will not differ in any respects. But here, from the latest researches, we see that there is difference. According to him, there are certain drawbacks. Those are atoms are divisible. He told that atoms are indivisible particles. But here we see that atoms are divisible and they can be subdivided into electrons, neutrons, and protons. Okay. Every atom of an element is not alike in all respects. Okay. He told that every atom of a single element, they are similar. But here, according to the latest researches, it is proved that every atom of an element is not alike in all respects. This is due to the fact that there are isotopes, that is having the same atomic number, but their mass number may differ. That is, the number of neutrons may vary, and according to that, their mass numbers differ. So here also Dalton's atomic theory is proved wrong. Then atoms always do not combine in small whole numbers. Okay. Example, the molecule of stearic acid is a formula C17H35COOH, which is not a small whole number. And according to Dalton, he said that the atoms combined in whole numbers. But here, according to the latest researches, it is proved that atoms do not combine in small whole numbers always. But atom is still the smallest unit of matter which takes part in a chemical reaction. That is correct. Okay, the atom is the smallest unit of the matter which takes part in the chemical reaction. Okay, now these are the contradictions of Dalton's atomic theory. Next, we come to electronic configuration. The electronic configuration is the arrangement of electrons which are arranged in the cells or the parts which are which are arranged around the nucleus. The parts, the imaginary parts or orbits or shells which revolve around the nucleus, and the electrons are arranged on these orbits or on the shells. Okay, so these arrangement is known as electronic configuration. These arrangement of electrons is known as electronic configuration. The orbit which is closest to the nucleus is known as the first orbit, and then it goes on second, third, fourth, and the last one is the valence shell. Okay, which contains the valence electrons, which denotes the valency of the element. Okay, they're labeled as K, L, M, N, or 1, 2, 3, 4 from the shell which is close to the nucleus. Okay, outwards. Then each of these orbits or shell contain number of electrons depending upon the amount of energy which is associated with them. Okay, how much energy the electron has, according to that, the different number of electrons, they contain the number of electrons. Okay, then the shell which is closest to the nucleus has the lowest amount of energy, and so it contains least number of electrons. Okay, that is the shell which is closest to the nucleus that has lowest amount of energy, because it requires less amount of energy to to hold the electron towards the nucleus. Okay, attraction force of the nucleus to the electrons are held by the nucleus by an attraction force, so that is more. Okay, so it has to spend very less amount of energy to hold itself in that shell. So that's why that there is a least amount of energy which is present in the shell, in the closest first shell. That's why there is least number of electrons. Okay, and furthermore, it increases as the shells increase. Okay, now rules of writing the number of electrons in different energy levels. The maximum number of electrons which is present in the shell or the orbit is determined by the formula 2n square, where what is the n? N is the number of shell. Okay, so if it is K shell, then n is equal to 1, then number of electrons will be 2 into 1 square, that is 2. 2 electrons are present in the first cell, K shell. L, if the shell number is 2, so n is equal to 2, and number of electrons will be 2 into 2 to square, that is 2 into 4, that is 8. That is 8 number of electrons will be present in the second shell, that is L shell. Then third, the shell, therefore n is equal to 3, M shell that is, and the number of electrons will be 2 into 3 square, that is 9. 2 into 9, that will be 18. At the most, 18 number of electrons can be present in the third cell. Then N shell, that will be fourth cell. Okay, so that fourth cell will be fourth cell will be n is equal to 4, that is. The number of electrons will be 2 into 4 square. Okay, so 4 square, that is 16. So 2 into 16, that is 32. At the most, 32 electrons can be held in the N shell, that is the fourth shell, fourth number shell. So this continues as much shell it will have. Now, electrons can accommodate in a given shell unless the inner shells are filled. That is, as in the stepwise manner it goes, that one shell is filled up, then it goes to the next shell. But the outermost shell of an electrically neutral atom cannot accommodate not more than 8 electrons. So it will not accommodate more than 8 electrons. Okay, the outermost shell. This is known as octet rule. Even if the compound, even if the element has say 2 shells, So the last electron, last shell will contain not more than 8 electrons. Okay, this is known as octet rule, OCTET. Mind the spelling, octet rule. If an atom has only one shell, like hydrogen and lithium, the outermost orbit has only 2 electrons. This is known as duplet rule. Okay, if an atom contain only one shell, like hydrogen and lithium, the outermost orbit, that is the valence orbit, okay, valence shell, so that will contain only 2 electrons. This is known as duplet rule. Example, helium, which has 2 electrons, lithium, which has 2 and 1 electron, that is 1 in the outermost shell, 2 in the first shell. Nelium, which has 2 electrons in the first shell and 8 electrons in the sorry, not nelium, it is neon. The outermost shell has 8 electrons. Then potassium has 2 in the first shell, second 8, third 8, and last is only 1. Okay. Now, the valence shell is the outermost shell of an atom, and it is also known as valence orbit. The electrons which are present in the valence shell are known as valence electrons, that varies from 1 to 8 for the different elements, determining the valency of the element. So how much electrons which are present in the valence shell, that will determine the valency of the element. Okay. Then the knowledge of atoms helps to determine how molecules of the elements and compounds are formed, whether atoms of the same element or of different element combining. Okay. So if we know the atoms, that will we have the knowledge of the atoms, then we can determine how the molecules of the elements or compounds are formed, whether it is formed by the compound is formed by the same element or it is of different element combining. Okay. Now, example, 2 atoms of oxygen which combine to form 1 molecule of oxygen, and 2 hydrogen atoms combine with 1 oxygen atom to form 1 molecule of water. Okay. Next is chemical bonding. Okay. Chemical bonding, it's the force of attraction between 2 similar or different atoms with in a molecule to form a molecule of an element or a compound. Okay. In a molecule to form an element or a compound. See, the force of attraction between 2 similar or different atoms. When it is forming a molecule of an element, then 2 similar atoms are there of the same element. And if it is forming a compound, then it has 2 different atoms of 2 different elements forming a compound. In a molecule, it's forming a molecule, no? So in a molecule, if it is of similar element, then it is forming a molecule of the same element. And if it is of 2 different elements, then it is forming 2 different atoms of 2 different elements, then it is forming a compound. So while forming this molecule, there is a bonding which combines them, combines these atoms. Okay. So this is known as chemical bonding. Okay. Which the formation of the chemical bond decreases the energy between the combining atoms. Okay. When the chemical bond is forming, what happens? The energy decreases between the combining atoms. The combining atoms have certain energy levels. Now that decreases when the chemical bonding is formed. This forms a more stable molecule than the individual atoms. When the atom stays individually, it is not stable because it has some electrons in the valence shell which may not be stable, because if it has 8 electrons, then it is stable. Okay, the outermost shell. But if it has less, if it is less than 8, then it is not stable. When it combines with another atom of the same or different element, then what happens? That it becomes more stable, forming a molecule. So it becomes more stable. Therefore, atoms combine to form molecules in order to attain the chemical stability, as they have incomplete valence shell that I told you. then actually elements try to attain a stable electronic configurations of the nearest inert gas. That is, it may be duplet or it may be octet. Okay, nearest inert gas. Okay, so inert gas has our valence shell 8 electrons. Okay, so the elements which are not stable, they try to attain that octet or duplet condition. That is 8 electrons in the valence shell by gaining electrons or by losing it or by sharing it with other atoms. And in doing so, they form a bonding and form a molecule. Okay, by losing or gaining electrons, an atom develops either a positive or a negative charge. As the valence of the positive and negative charges become unequal, this forms ions. Okay, so when this combination is being taking place, when this chemical bonding is being taking place, when two atoms of the same or different element is combining, at that time, what does the atoms do? They either lose electrons or they gain electrons. Okay, if they have only very less number of electrons in the valence shell, they generally lose electrons. And if they have more of this valence electrons, then they try to gain electrons to form the octet or duplet. Okay, so accordingly, if they gain electrons, their negativity increases. The negative charge of the atom increases and it becomes negative ion. And if it loses electrons, that means its negative condition, negative charge decreases, so it becomes positively charged ion. Okay, so losing electrons forming positive charge, that is cations, and gaining electrons forms negative ions, that is anions. So atoms combine with one another according to their combining capacity, which is known as valencing. Okay, so atoms, they either lose or they gain electrons according to their combining capacity, which is known as valencing. I'll discuss the valency later on. Okay, so in my next video, I'll continue this valency part. Okay, so till then, please go through this. If you have any doubt, please do let me know. Do write in the comment box. You can also refer to my email ID, kasturi74@gmail.com. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And do subscribe to get the notification of my next video. Thank you. Thank you for watching and have a good day.